Good morning, everyone. So you should have already grabbed this document. This is document number 40, 421 and 422 on Google Classroom. And what we're going to be looking at in this document is back to trigonometry. So when we were talking about tangent. And when we were talking about tangent, we had the legs of a right triangle. So that means the sides touching the right angle. But sometimes we're not going to know those sides. We're only going to know the hypotenuse. So we're going to figure out how we can use trigonometry to find missing sides of a triangle when we have the hypotenuse. Now, before we do that, what I would like you to do is on Classroom is get the second document that's on there. It is a graphic organizer that looks just like this, right triangle graphic organizer. And we're going to fill in some of these tools. Okay, so the first tool that we're going to fill in, the first two are review, the Pythagorean theorem, and tangent. So what I would like you to do, we're going to pause this video right here and you are going to copy these two tools down. Now that you have these copied down, what we're going to do is we're going to use tangent in order to solve for some right triangles. Now remember, if you slide from the left-hand side in Notability, you'll be able to split your screen with two documents, so you can still have this graphic organizer open. And then you can come to assignment number 40 and hit the three dots, and you can view it on the right or the left. So what I would like you to do is I would like you in your groups to spend about 5 minutes doing these first two problems. Problem number 1 and problem number 2, where we're using tangent to find those missing sides. So we're going to pause here and give you those 5 minutes to do that. Now that you had time to solve for those two, let's look and see what answers we get. So you should have, for the first one, your equation should be tan of 24 degrees equals x over 12. And when you solve for x here, you're going to multiply both sides by 12. And you should get that x equals 5.34. For number 2, you're going to have tan of 55 degrees equals 29 over x, because x is now our adjacent side. It is now touching our angle there. So it's going to be a little bit differently. You're going to end up dividing 29 by the tangent of 55 degrees. And when you do that, you're going to get x is 20.3. So a little bit of review for tangent. Now let's start looking at, okay, what happens if we don't have our two legs, or we don't have a leg? What happens if we have the hypotenuse? And remember, the hypotenuse here is the side that is across from the right angle. Okay? So let's look at this first problem. Juanisha is doing training runs up a hill. She knows the angle of incline is 31.5 degrees and that she sprinted 100 feet. She wants to know her elevation. But do we have enough tools to find her elevation, the delta y right now, change in y? And the answer is no, because we do not know what the change in x is. So no, we do not have the tools to find the change in y, because we do not know the change in x. Okay, so right now we cannot figure out how high she climbed. But what we're going to do is we're going to look at similar triangles, just like we did when we talked about tangent. to see what we can find. So to find how high she climbed, we need to know more about the relationship between the ratios of the sides of a right triangle. So what we're going to do for these two triangles here, we are going to find a ratio. This time our change in x, which is our run, over our hypotenuse now. So this is our hypotenuse for both triangles. So for our big triangle, it's 6, and for our small triangle, our hypotenuse is 2. So we're going to have two different ratios. Here is our run for both. Our run for the small triangle is 1, so I'm going to go 1 over 2. There's nothing I can simplify there, so that's it. Our run for the big one is 3, so we're going to have 3 over 6, which is our hypotenuse. This one I can simplify, and I can divide both of these by 3, and I will get 1 over 2. So as you can see, both of these ratios are equal, and these must be equal because these two triangles are similar. So if this is 60 degrees, that means this angle right here is also 60 degrees. And they both have right angles there, so they are similar. The triangles are similar by angle similarity, one of our 5 similarity theorems that is on the board. So since they're similar by angle, and this one is also similar by angle, since it has a 60-degree angle and a 90-degree angle, I can set up a proportion, and I can solve for our missing side, for side BC right here, by solving that proportion by cross multiplying. So the proportion, our change in x over the hypotenuse, so x over 7 for this triangle here, equals the ratio that we got for the other ones, 1 over 2. Now we know how to solve these proportions here. All we would do is cross multiply, and we would solve that way. So cross multiplying gets us 2x equals 7, and when I divide both sides by 2, I get x equals 3.5. Okay, so this would also work for finding the height of our triangles here, our change in y, if we knew the hypotenuse. So both of these similarity ratios, these slope ratios, kind of like when we had the tangent ratios, they have a special name. All right? When we have our change in x, our run, over our hypotenuse, we call that the cosine. So a change in x over the hypotenuse is our cosine ratio. And when we have our change in y over our hypotenuse, we call that our sine ratio. So just like our tangent was our change in y over change in x, these ratios have special names as well. Okay, so what you're going to do now is we're going to go back to our graphic organizer, and you are going to take a moment and you are going to write down the ratios here. So remember that our opposite is like our change in y, our run, and our adjacent is like our change in x. So we're going to pause here and give you time to write these two tools down, because then we are going to use them. Now that you have these written down, we're going to practice using these two tools. So I'm going to split my screen, so that I have my tools open. We have all of our tools here so far. And my problems open here on the left. So we have sine and cosine. We're added those to our graphic organizer. So now we are going to use them to find some missing sides. So what I'm going to do on both of these here is I'm going to label my sides as opposite, adjacent, and the hypotenuse, just like we've done before. So in the first one, I'm giving 23 degrees. So if I look here, here's my opposite side. The second one, I'm given 37. So across from that is my opposite side. My adjacent side is touching my angle here. So this is touching the angle, and this one is touching the angle down here. So this is my adjacent side. And then our hypotenuse is across from our 90-degree angle. So here's the hypotenuse for the first one. And here's the hypotenuse for the second. All right, so now in our first triangle here, I'm given A and 15, which is the opposite and the hypotenuse. So if I look at my graphic organizer, I can see that the sine uses the opposite and the hypotenuse. So for letter A, we're using the sine ratio. We're going to say sine of our angle, which is 23 degrees, equals, looking at my graphic organizer, I'm going to have my opposite side, which was A, over my hypotenuse, which is 15. Okay, so I would solve this just like I would the tangent ratio. I would get A by itself by multiplying 15 on both sides. That would cancel this 15 out. So now I would have 15 times sine of 23 degrees equals A. So what I'm going to do is I'm going to go to Desmos, my calculator. I'm going to make sure that this wrench here, we have degrees selected. And now I am going to write in what I had. We had 15 times sine of 23. And I get 5.86 or 5.9. So back here, I'm going to write that A equals 5.9. Okay. Now for our second one, I am given B, which is the adjacent side, and 8, which is our hypotenuse. So I can see from here, my graphic organizer, cosine is the adjacent and the hypotenuse. So I'm going to write an equation using the cosine now. So cosine of our angle is 37 degrees equals our adjacent side, which is B, over our hypotenuse, which is 8. Just like I did for sine, I'm going to solve this by multiplying by 8 on both sides. And in my calculator, I'm going to plug in 8 times cosine 37 to get what B is. So 8, times cosine 37, and I get 6.38 or 6.4. So that is what B equals, 6.4. Okay. So now that we know how to use the sine and cosine, very similar to tangent ratio, we can answer our last question, was how high Wanisha climbed when she was going up the hill. So how high she climbed is our change in y right here, which is opposite of the angle we have. Okay? And the 100 feet that she climbed is the hypotenuse. So I'm going to look at my graphic organizer, and I can see that, again, I'm going to be using sine because I have the opposite in the hypotenuse. So I'm going to have sine of 31.5 degrees equals change in y, which is our opposite, over 100, which is our hypotenuse. And just like we did for letter A in number 58, I'm going to multiply by 100 on both sides. And in our calculator, we'll type in 100 times sine of 31.5 degrees. And remember to have your calculator in degree mode. Okay, so 100 times sine 31.5 equals 52.2 feet, since we're talking about feet now. All right, so very similar to tangent, just now using different sides of our right triangle. So what you're going to do in your teams, you are going to be working on number 68 here, where you're using your graphic organizer to determine which trig tool you're going to use to solve for the missing side. So first, label each side as opposite, adjacent, and hypotenuse, especially the sides that you're given. Then you're going to ask yourself, am I using cosine? So I have the adjacent and the hypotenuse. Am I going to use sine? Do I have tangent? Or I'm sorry, do I have opposite and hypotenuse? Or am I going to use tangent because we have the opposite and the adjacent? You're going to write an equation like we did up here, and you're going to solve for x. So you will be working on that for these 6 problems on the next page. And then when you finished, you should write your learning log and add that to your fall notebook. So you'll be working on this for the period. The sub will be coming around to help you and to answer any questions you might have. And at the end of the period, you'll be checking your work. If you finish early, you are to work on your homework. You have 4 problems. First one is some trigonometry, just like you're practicing in class. Same with number 63, but there's nothing for you to solve there. We're graphing. Use Desmos this time. And then we have a little probability. So again, now you are using your graphic organizer to solve these 6 problems, and you're getting X. Okay? Get to work.